So let's get started. You'll need your EL, or I keep saying EL today, math spiral. We're in math. And you're going to need your math workbook. My friends at home are going to need their little tile squares that you cut out on Friday. Remember, I said don't lose those. You will need those. So that's what we're going to start with here pretty soon. Sorry, we're not on slide 10. Quick review. Let's see if we can do 168 plus 458. We're going to do this in our math spiral. Let's have Lucas walk me through this. Have I had to solve a problem that involved possibly $168 plus $458? How would I do it?
So 8 plus 8 is 16. You carry the 1 over to the 6. And
All right.
6 there. And 6 plus 1 is 7. 7 plus 5 is 2.
Okay, hold up. Hold up. Hold up. Let's try that again. All right. I heard 8 plus 8.
8 plus 8 is 16.
So now it's on.
So how many pages?
Stop, Penny, because I'm having technical difficulties. We're going to try again. All right, let's try again.
8 plus 8 is 16. Put the 6 there, carry the 1 over to the 6. And
Okay.
6 plus 1, 7 plus 5 is 12.
So if you didn't hear Lucas, he said 8 plus 8 is 16. Put the 6, carry the 1. Then 1 plus 6 is 7. 7 plus 5 is 12. Put the 2, carry the 1. What's 1 plus 1 plus 4?
That would be 6.
Awesome. All right, let's write the next problem. So August, you're writing this, sweetheart. All this is, you have to write that. Come sit right here, bud. Where's your pencil? So guys, you're not sitting here watching me do this work because I know how to add really well. This is your practice. You should be going ahead to the next one. Where's the first one? No. See if you can follow along with us, okay, Josh? Because that's not what I did, see? Are you watching? Yeah. Okay, pay attention. Then you should have what I have, right? All right. I was just making sure everybody has it. Let's move on. Ellie, if I had $312 and I spent $235 on fun stuff, how would I figure out how much I have left?
So you can't do 2 minus 5. So you take away from the 1, make it a 0, turn it into a 12. 12 minus 5 is 7.
Okay,
And then 6.
that's a 0.
And then,
Can I do 0 minus 3?
no. So you go over to the 3 and you make it a 2. And then 10 minus 3 is 7. And you can't, and 2 minus 2 is 0.
So do I write the 0?
No.
A lot of people are writing the 0. Don't put that 0 in there because we wouldn't write that. If I said I have $77 left, I wouldn't put a 0 in front. Nice done, nicely done. All right, let's hear from Astria. I have 4 equal sides and 4 right angles. I am considered a parallelogram and a rhombus. What am I? I'll give you some time to think. Write your answer in your spiral. I have 4 equal sides, that's your clue, and 4 right angles. I am considered a parallelogram and a rhombus. What am I? Write it down in your spiral. Write the word. What is the word? Do your best with spelling. Good job. Yeah. Ooh, I'm so impressed. Yes, 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 yes. Astrid, do you think you know, my dear?
It's a square.
Yay! You're right. What gave it away?
Is that it has 4 equal sides and right angles, and also that it was considered a parallelogram and a rhombus.
Yeah, because if you would have said rectangle, a rectangle doesn't always have equal sides, and it is not a rhombus, right? So there you go. It had to be square. 7 times 7. 7 times 7. Write your answer in your spiral. 7 times 7. Lucas, write it down. 7 times 7. Write it down. All right. Max Fox, what do you think? Max Fox says 49. Give a thumbs up if you agree. How do you know 7 times 7 is 49?
Because everything that is counted is 7 by 7.
Did you start with maybe a higher? You didn't say 7, 14, 21. Did you do it that way?
Yeah, I did that one.
Can I give you a trick? You could start with a higher number, like what, Sonny?
Like 7 times 5.
Like 5 times 7, which is what?
35.
35. Then add 2 more 7s, right? 35, 42, 49. 36 divided by 6. I'm going to pick out of my dandy can, Haley Booker.
36 divided by 6 is 6 because I remember it says 6 times 6 is 36.
So Haley Booker said 36 divided by 6 is 6 because she remembers 6 times 6 is 36, which means she's using the inverse operation, right? That's a great strategy. All right, go ahead and do the next two. Round 36 to the nearest 10 and 123 to the nearest 100. I'm going to give you a hint. Look at the 6 when you're looking to round 36. Look at the 2 when you're looking to round 123. Write it down in your spiral. Hold it up when you have it. What are you going to round those 2 numbers to? Don't forget, 5 and above, give it a shove. 4 and below, take it down low. Nice. Nice, nice, nice. All right. All right, Reese, go for it. Tell us what you did and why.
Because 6 is higher than 4, you give it a shove to 40, and because 2 is lower than 5, you give it a shove to 100. I meant you take it down low to 100.
Excellent. Well done, Reese. Thank you for sharing. If you agree with her, give her sparkles. You should all be sparkling. All right. Well done. We haven't had time for a review in a while. Probably still didn't, but wanted to do it anyway. So today we are going to use side lengths and area and perimeter calculations and problems. So continuing our work with area and perimeter, so we can solve real problems that involve perimeter and area, like fencing and gardens, right? That kind of stuff. So we're going to be able to record the results of tiling a rectangle by using the distributive property. Give me a thumbs up if that sounds familiar. Distributive, we just did it when we said 5 times 7 is 35 and then 2 more 7s is 14 and added them together. We distributed it. That sounded funny. Then we're going to find unknown side lengths of a rectangle when we know one side length. All right, let's keep going. You've got a quick song for you to get your brain back in gear with area and perimeter. Let's see if I can get it a little louder.
That's the space inside for a rectangle. It's length and width of multiply. Perimeter, the distance around the shape. Just add the sides together and then you'll be great with the area. That's the space inside for a rectangle. It's length and width of multiply. Perimeter, the distance around the shape. Just add the sides together and then you'll be great. Yeah, here I am on Mars, trying to find out the size of my backyard. But it's a rectangle, right? So what if we cut it into squares of the same size that are 1 unit long by 1 unit wide? These are called square units. Add them all up, surprise! Got 72 square units, because that's the unit where you sit. But who has time to count squares? Length times width is the quickest way to get there. Yeah, that's how you find the area. A nice little formula that'll take area. And I need to hurry cause my dog is starving. Let's find the area so I can feed Marvin. My yard is 9 feet long by 8 feet wide. I get the area when I multiply each side. 9 times 8 is 72. Here's another way for you to take it through. Basically, you take the rows and figure how many square units fit inside of those. Yo, my backyard is wide, 8 feet. So that's 8 rows with 9 square units in each. So multiply the 8 rows by the 9 square units. You get 72. Yup, you knew it. Area. That's the space inside for a rectangle. Its length and width of multiply. Perimeter. The distance around the shape. Just add the sides together and then you'll be great with the area. That's the space inside for a rectangle. Its length and width of multiply. Perimeter. The distance around the shape. Just add the sides together and then you'll be great. Now I've got my area for my yard on Mars. And there's plenty of room for Marvin to live large. But now I need a fence cause I heard the animals on Mars could be intense. So I'll need a perimeter, the distance around my whole yard. How do you get it? Yeah, just add up the length of the sides. 9 plus 8 plus 8 plus 9 is a perimeter of 34 feet. And oh yeah, that's regular units and not units squared. So let's take a look from another angle. To get the perimeter of a square or rectangle, you add 2 widths plus 2 lengths. Here's a formula, don't forget to say thanks. 2 times length plus 2 times width to get a square or rectangle's perimeter quick. So let's try it with my Martian backyard. Come on, get ready, y'all. It's not that hard. 2 times the length of 9 is 18, and 2 times the width of 8 is 16, and 16 plus 18 is 34. Now, if I can stop Marvin from making a dirty floor.
All right, I love that vocabulary. I can find it on YouTube sometimes. Nice. Okay, so what did you hear about area and perimeter? What do you remember? Oops, sorry. What do you remember about area from Friday? Lila?
Area is the square units or measure inside a shape. And
Okay, stop there. So area is the square units inside a shape. It's the space inside, within. What is the perimeter? Elena, if area is the inside, what's perimeter? This was your exit ticket on Friday. Is it the inside of the shape or the what? It's the opposite kind of, right? It's the outside, it's the side lengths, the distance around, how much fencing you would need if you were going to fence in your yard or a garden. So on Friday, I asked my remote learners to cut these out. I am going to give my in-person some tiles, so I'll be coming around with those in a moment. But let's look at 319. So you'll need your squares and you'll need page 319. Here's what, before we pass those out, I just want to go over the directions with you. We are going to use the 1-inch unit squares to cover the rectangle on this page. So be sure there are no gaps between your squares and that they do not overlap. Now it tells you on this page to draw lines to show the unit squares. You don't need to do that, okay? You don't have to draw the lines. That could take all day long. So we're just going to fill this up, see how many square units it is across the top for the length and down the side for the width. You're going to write the numbers there. And then you're going to see, can you find the area by counting those tiles and also by writing a multiplication equation to show the area. So any questions? Because I think I'm going to just let you do this. Any questions? If you need to rip the page out because your book won't sit flat, you can rip it out if you would like. All right, Ellie has a question.
I wasn't here on Friday.
Right, because you were absent. Okay. All right, so go ahead and get started as soon as you can. Did anyone else have a question about what we're doing?
I'm almost done. Thank you.
Pretend you work for Home Depot and you're getting to tile your bedroom. Thank you.
Get everybody? Yeah. Thank you.
Once you find your side lengths, find the area. Make sure you label it with square units and then write an equation. Multiplication equation down here. Okay, when you're done, but make sure you write your lengths here. No, remember, don't worry about that. Just this, and this. All right? Guys, the top numbers are just giving you directions. Now, listen to what I'm saying. Guys, numbers 13, I read this with you. You don't have to do anything for that. I already told you, check whether there are any gaps. Make sure there are no gaps. I said, make sure your squares don't overlap, right? You don't need to write anything there. And I asked you not to do this. I said, please don't do that. We don't have time, right, to draw lines around them. So all I'm asking you to do, and I don't want you to do that. All I'm asking you to do is put your tiles down. Tell me the side lengths. And then I do want you to do number 18, which says write a multiplication equation to show the area. Don't forget to label it with square units. These are inches. So guys, you can actually, these are 1-inch tiles, so you can label it square inches since we are doing area. Okay, give me a number of minutes that you think you need to finish. 0, 1, 2, 3. Thank you, Reese. I see you. All right, I'm gonna give you another minute or so. 0 for Leo. Oh, I made a rhyme. 0 Leo. 0 Leo. It rhymes, right? Same sound at the end. It rhymes. Can I borrow you a little bit? Can I rip this page out? Thank you.
Don't forget your label. Square inches.
All right. We're gonna go ahead and, oh, I hate doing that. Check it out. Let's see how you did. You should have pretended you worked at Home Depot. You're a construction worker. You came in to tile the kitchen floor. And because you didn't want any gaps or spaces, should have looked something like this going across. Thumbs up if you got 5 at the top. Yeah? Nice, Madison, I see you. And then you should have gotten how many, Leo, on the side or the width?
3.
3. And what would the area of this rectangle be? Leo, what do you think? I can fill them in for you, or you could just use your side lengths and what you already know. It's called a quick array, right? What'd you get, Leo? How many tiles are there?
15.
Excellent. And what would the multiplication equation be for that, Leo?
5 times 3.
Equals 15 what?
Square inches.
I love that he said square inches. Make sure you label that SQ. You can abbreviate. Okay, so that's what that looks like. You now should have all gotten that one. Should have been enough time. If you turn over to page 320, you will see there are 2 more rectangles that I would like you to do. Listen before you start. Cover each rectangle with 1-inch unit squares. Count the squares to find the area. Then also, so you have the area is, but then you have the equation is. So I want you to do both. And the reason for that is just to check your work. So that if your multiplication is off, you can still count them. You have 2 rectangles to do and then 2 questions. So we'll go over the, if you get to the questions, great. If you don't, we'll go over them together. All right, go ahead and start tiling. So you're on page 320 and you have 2 to do. You have those tile squares from Friday that you cut out. You don't have to draw them, just use the tiles to help you. So remember, area equals length times width. SQIN.
Don't forget SQIN. Okay, let's see how we did. Yeah, totally. Yeah.
I just,
That's first time.
all of a sudden I looked and I was like, wait a minute, someone's here that
Can
wasn't.
I try that again? That's so, I'm glad you mentioned it. All right.
Thank you.
You know,
All right, let's check our work. Let's see how we did. I'm surprised it hasn't happened sooner, actually. So I am going to tile this, see how it compares to your tiling job.
That sounds weird.
Tiling. My name is Tyler and I tile.
My cousin's name's Tyler.
So you should have gotten a length of 4 inches and a width of 1 inch. Thumbs up if you got 4 square inches. Excellent. And so if you counted them, you would get it, or you could have done 1 times 4 equals 4 square inch. Please do SQ period, IN period. That's the first one. Did anyone want to have a discussion about it or think differently? Everyone agrees? Okay. So as I tile this one, does this look similar to what you guys got? All right, I'm going to try just a fast array, Ben. If I do a fast array, can I still find the area of this rectangle? If I don't fill in the whole thing, can I figure it out, do you think? I bet you can. Let's count. 1, 2, 3, 4, 5, right? So if it has a length of 5, and what's the width? 1, 2, right? If it's a 2 by 5, don't I know that's going to equal 10? Are you with me, Ben? Do you see how I could use that quick array to figure that out? Okay. All right. Here, I'm going to prove it to you, Mr. Bowers. I'm going to put these in. Let's see if I was right. Let's count them. 2, 4, 6, 8, 10. So area should have been 10 square inches, and 5 times 2 equals 10 square inches. So how many 1 inch unit squares are needed to cover a rectangle that is 7 inches long and 4 inches wide? Max Deesberg, what do you think? He says 28. How do you know? So you can do 7 times 4 or 4 times 7. Because what do we know about area? What does it equal? Area equals times width. All right, and he says 7 times 4 is 28 square inches. So what if the area of a rectangle, what is the area of a rectangle that is 7 inches? Well, didn't it just say that? Oh, same thing, sorry. How many unit squares are needed and what is the area? Are those the same? That's the same, right? 7 times 4 equals 28 square inches. What if I said I had a rectangle that was a 2 by 6? How many tiles would I need, Robert, for a 2 by 6 rectangle? 2 inches wide, 6 inches long. What do you have to do to those two the side length and the width? You multiply, right? So what would 2 times 6 be? 12, right? What about a 3 by 4? What would that be? Everyone. What about a 4 by 5? 4 by 5. You have to multiply the numbers I'm giving you to find area, right? Because it's length times. What about 2 by 5? What about 3 by 3? 9. So I just want you to get it in your head that when you are finding area, yes, we can count tiles, but you want to move on from that eventually to just using those multiplication facts. Multiply length times width. Okay, nice job, you guys. Thank you for sharing. And it looks like we are moving on from tiling. So if you would please put your square tiles to the side, and I'm going to have you turn to page 321. So turn to page 321. Now we get to talk about distributive property. But before we do that, actually, I'm going to show you, you're going to need your math spiral because I want to give you an example. It's going to be 321. I believe is what I said. Let me double check. Yeah, 321. But before we do that, I want to give you a little example of how we're going to use distributive property to find area. You don't need your board. I'm going to use my board. You're going to write your answers in your math spiral. So let's put the tiles away. Get your math spiral and your pencil. Just set them to the side, Abby. I'll get them. Okay. Right now you don't need them. Get your pencil in your hand and your math spiral. So what if I had, and let me find the numbers I want. If I drew, let me find this again. Sorry, I have an example I want to give you guys. Give me just a minute. All right, if I had a rectangle that looks like this. Hold on, you'll know what I mean here in a minute. Don't mind that little wave I have. I know it's annoying. Yeah, it's just a problem with my board, unfortunately. All right, so say this is my rectangle. It's a pretty big rectangle. And I wanted to find the area of the whole thing. I want to find the area of the entire rectangle. What are some strategies I could use to do that? Miss Ellie, what are you thinking?
You would use area.
Okay, what do you mean by that? I would use the area to find the area? What do you mean? Like, I can find it many ways, right? Is there a way maybe I could use addition to find the area of the whole thing? How would I use addition to find the area of this? Any ideas? Cooper, how would I use addition to find out how many squares are in this rectangle?
You'd add 3 plus 7.
To find out how many are in the whole thing?
No.
How could I use addition to find the area of the whole thing? Sunnyco?
You would add all the squares to the right side.
Okay, so do you see 1, 2, 3? Could I add 3 plus the 3 on this one, plus 3 here, plus the 3 in this one, this column, 3 in this column, 3 in this column, and 3 in this column? Could I do that? Would that give me the area? That's one way I could do it. Is there a different addition problem, Lyric, that I could use? Instead of going down, what else could I do to find the area of this rectangle? Say it again. But how could I use addition? Instead of going 3 plus 3, what could I add instead? Okay, so how many are going across in rows? 1, 2, 3, 4, 5, 6, 7. So I could add 7 plus, how many are going to be in this row? 7 plus, how many in this row? 7. Okay, that's another way we could find it. Other ways we could find the area. Yeah, Robert.
I don't know what it is, but 3 plus 7 plus 3 plus 7.
Well, these are our addition ways because we have repeated addition. So I don't think there's any other ways we're gonna, unless you wanted to count all these and add them together. We could do that. Josh Lewis? We could use multiplication. Exactly. Yeah. So repeated addition is the same thing as multiplication. So sure, I can add all these 3's up. 3 plus 3 is 6. 7, 8, 9. Count with me. 10, 11, 12. 13, 14, 15. 16, 17, 18. 19, 20, 21. And I would tell you that's 21 squared. Or I could say 7 plus 7 is 14, plus 7 more is 21. Because really what I'm doing is multiplying. Because area equals length times width. Length times width. So what would the multiplication problem be, Josh? Do you know?
7 times 3.
You could do 7 times 3. And because of the commutative property, they're both going to equal 21. Now, what if 7 times 3 is a little tough for me? Is there any way I could use the 2 colors to help me? And then maybe that distributive property. What are you thinking, Max?
So, I see the red one is actually 9.
Okay, so Max is saying, let's look at the red one first. And you say the area is 9. How do you know?
Because I see 3 columns and each has 3.
So that would be 3 times 3, right? Is that right? And he knows that equals 9.
And then I look at the blue and so that is exactly the same except for it has 3 more columns.
So this is a 4 by 3, right? So what would the multiplication be for that area? 4 times 3. Let's go ahead and have you figure that out and see if it equals 21. Do you think it will?
Yeah. Yeah.
Let's try it. 3 times 3 is 9. What's 4 times 3? 12. All right, add them up. See what you get. And then if that works, then we will have used distributed property. So I'm gonna have you do this right in the math spiral, right? All right, Jensen, can you unmute? Tell me what you got.
For what again?
9 plus 12 for the distributed property that we're using to find the area of this rectangle.
I got 21.
Yay! Is that what we all anticipated, predicted? Yeah, 21. So either way we do it, we're still gonna get 21. This distributed property is helpful when you get to the point where your numbers are so big that you're like, I don't even know how to multiply those. I'm gonna break it down. So it's just what we did when we came to 7 times 7. And some of us are like, I don't even know what that is, but I know 5 times 7. So let's do that. Let's do 2 times 7 and add them together. That's all distributed property is. It's really to make things easier. So let's try using it to find area on some of these rectangles. How about that? All right. So now we'll look at 321. I think it'll make more sense now that we did that. All right. So on 321, it's asking you to show 2 ways to find the area of a rectangle that is 10 units long and 6 inches wide. I'll do the first one with you and see if you can come up with the second one. So this looks really confusing, right? You're probably thinking, why don't we just do 6 by 10? Because you guys know that. It's not that it's too hard. We just want to show you in an easy way how to use distributed property so that when you do get to bigger numbers, you'll know how to break them apart. And we know you can break 10 apart pretty easy. How could I break 10 apart into 2 numbers that if I added them together, it would equal 10? What 2 numbers can I add together that would equal 10? Lyric? Okay, but I'm looking for 2 numbers I could add together. What could I add together? Charlie Carr?
5 plus 5.
I could do 5 plus 5, sure. So I could pretend this is straight down the middle, and this is 5, right? Let's see. And this is 5, and this is still gonna be 6. So if I wanted to find the area using distributive property, I would have to find the area of this part of the rectangle first. And then let's make this one green. And this part second. Because we know opposite sides of a rectangle are equal, this is also a 6. Go ahead and figure that out. Write it in your workbook. Get your pencil. You're on page 321. You are doing this. You guys decided to divide this in half, make it a 5 by 6, yes? Let's see it. Nope, let's see it. I'm going to see you doing your work. See if you can find the area by breaking it up into 2 squares, well, rectangles, and then adding it up together. Use that distributive property. Good job, Lyric's got it. So remember, this is a multiplication sign. Area equals length times width. So you're multiplying. Multiplying. Regular half. 5 times. Yeah, we will. 5 times 5. Multiply.
Because this whole thing here is 10. This whole thing from here to here. There's 5. What's 5 times 6? So 30 in that square. And then 33.
All right. Leo, what do you think? What would the area of the blue rectangle be? If it's a 5 by 6?
5 times 6 is 3. And then what's over here?
All right, Henry, can you unmute and tell me what you got for the area of the first part of the rectangle?
30.
Awesome. What about the green one, Henry?
30.
So what would the area of the whole thing be?
60.
You're so smart. So you should have had 6 times 5
Work on your,
plus
3.5.
6 times 5 equals 60 square units. If you have not written that, write that now, because this is distributive property. I want you to get used to that. All right, we need, Gavin, we need 2 numbers that, if you add them together, will equal 10, that are not 5 and 5, since we already used it. Can you think of any, Gavin?
6 and 4.
Awesome. All right, let's do it. Break it up. We're going to have 6 on this side. And this is still going to be 6, because that's how wide it is. And this is going to be 4, and this is going to be 6. See if you can find the area of that rectangle based on what Gavin gave us. If this side is a 6 by 6, this is a 4 by 6. Remember, you need an equation in parentheses and another one. Fill it in. See if you can find the area. Distribute it. Good job. What and what? These. See if you can add those parentheses, guys. That's good practice.
That's an equal sign?
This? It says inches for unit. Oh, units. It's UN for unit. Well, I think her pen was not.
How you doing? So where do you think on your own? Try it. 6 times 6 plus 4 is 6.
You guys know 6 times 6, right? 6 times 6 is 36. There you got one of them. So Mrs. Alvin, I noticed that several people are trying to draw the little lines inside, and it's not a good idea to count. It's more of a better idea to use our multiplication skills, right? So this, because it's not on lined graph paper, there's a reason for that. Do you remember when I said, okay, we showed you with the tiles, but we want to move on from the tiles because it's more efficient? That's why we got to have our facts memorized as well. So don't draw, use the formula, area equals length times width. So what's 6 times 6? Microphone answer?
36.
So I would have said 6 times 6 is 36. And then I would have said 4 times 6 is, anyone know?
24.
24. When I add 36 plus 24, I get 60, which is what we would have known anyways, because we knew it was a 10 by 6. And that one's pretty easy. 10 times 6 is 60. But I just wanted to make it easy for you to understand how you could distribute it if it were numbers that were really difficult. Okay. All right, I don't think we're going to worry about this. Nope, that's all we're going to do on this. So let's say goodbye to page 321. I hope that gave you a little bit of understanding of how we can use distributed property to find area of larger rectangles where the numbers just get really big. So I'm going to do one with you, and then I want you guys to work on these on your own. Here is the first one. We'll do this together. Do it in your workbook so that you can see an example for when it's time. Here we go. The first, it's just like what we did. Cooper, you ready? Max, ready? Here we go. We have one. I'm going to make this the red one, and I'm going to make this one the green one. It's just what we did. I'm going to first put the area in the red, 3 times 4, plus finding the area of the green section. This is also going to be 4, 5 times 4. Go ahead and write that because this is what you're going to be doing on the others. First, I have to find 3 times 4. Well, I know 3 times 4 is 12. I'm going to write that above. And I could even write it inside the square if you like that. Or not a square, it's a rectangle. I don't know why I'm doing that today. 5 times 4, 5, 10, 15, 20. I could write 20 here. Write it here. I have to add them together to get the total area, and that is 32 square units. So that's how we're going to do these types of problems. You're going to write them in parentheses, add them together using distributive property. When you come down to number 10 through 13, it says draw a rectangle for each equation. So if it says 3 by 3 plus 3 by 5, I would draw my rectangle and I would just divide it like so. 3 by 3 and 3 by 5, right? That would be, I don't even have to find the area. That's pretty nice. Nice. Okay. Any questions on what we're going to do on this page? Now you're just practicing what we did before. Yes or no? You're going to do this page as much as you can in the time I give you. Okay, and I'm fine with you guys working in partners. So I'll put my kiddos at home in breakout groups. And if you guys want to work with a partner, make sure you got the examples on your paper so that you can use those to help you. Any questions at home before I put you in breakout rooms? We're going to finish that page, okay, on page 322. All right, if there are no questions, I'll go ahead and have you join your breakout room.
Guys, okay.
This is my favorite part.
So much to do. All right. Welcome back, guys. Vista 5, how did you do in your breakout rooms with distributed property? Vista 5. All right. Okay, Haley. All right, let me just share my screen again, get back to where we were. So you should have done something similar to this. 2 times 5 plus 4 times 5. And a hush fell over the crowd. Okay, much better, thank you. And gotten 10 plus 20, which equals 30. Did you and your partner get that? Don't forget square units. All right, then for number 8, you should have seen this was a 3 by 3 plus, since we know opposite sides are equal, a 6 by 3, which just means to multiply. 3 times 3 is 9. 3 times 6 is 18. Add those together. You should have gotten 27 square units. And then this one was kind of lucky. Finally got my squares. 4 times 4 plus 4 times 4. 16 plus 16, and you should have gotten 32 square units. All right, I'm not going to go over the drawings, but this was what the meat. Show me how you did. That's hard stuff, guys. Distributive property. If you are still feeling like this is a little bit tough, it's okay. If you're feeling like this is a lot, distributive property, I see you, Bennett, too. Don't panic. We'll be doing more of this. You'll hear about distributive property all through middle school and high school as well. Okay, guys, nice work today. Don't forget your Think Central. If you are in person, you may get your goodies and head back to your homeroom class. Thank you for your hard work. You just sit there. Thank you.